Hello, everyone. Welcome to the Carolina Weather Group. This is show number 284, and we have Dr. Ben Mirus on. He is a research geologist with the USGS, and we're happy to have Ben on with us tonight. We're going to be talking about landslides, and so as we enter the tropical season and we could see some heavier rains from tropical storms and hurricanes, I'm sure we'll talk about the threat of landslides. So our goal tonight is to kind of get you caught up with what a landslide is, maybe where they will happen, and maybe some triggers. So when we do see those tropical systems move through the area, you'll have that little bit of a heads up. This is an interactive show. We'd love for you to interact with us. You can watch us right now on Facebook Live, Periscope, and on Twitch. And if you're listening on our podcast devices, we'll let our guests give you some information, maybe how you can find out more about landslides towards the end of this show. So again, this is show number 284. I do want to mention that we do have a severe thunderstorm warning in effect for central Greene County and eastern North Carolina, as well as Lenoir and Pitt County, and that goes until 9 o'clock. This severe thunderstorm was just issued about 10 minutes ago. The storm could be producing 60-mile-per-hour winds as well as penny-size hail. So again, some of the locations would be Greenville, Whitterville, Ayden, Farmville, Snow Hill, Belle Arthur, Blackjack, Maury, Roundtree, and the East Carolina University. I know we have a weather stem camera there at East Carolina, so maybe we can draw that up at some point during the show. So anyways, that is the severe weather. That's the only severe weather warning that we have in the area, but we'll continue to monitor the radar throughout the show, and if anything else breaks out, we'll be sure to update you. That severe thunderstorm warning out for the Greenville, North Carolina metropolitan area. I know President Trump's there tonight, so a lot of people there at East Carolina University. So if you know someone there, just be mindful of that and let them know that, hey, there's a severe thunderstorm around. So anyways, I will toss it over to our guest tonight. We have on with us Dr. Ben Mirus. Again, he is a geologist for the USGS. Ben, welcome to the show. You're there in Golden, Colorado, so we welcome you to the show tonight.
Great. Thanks very much. Great to be here.
Yes, we're happy to have you, Ben, and we know that you have been doing a lot of research on landslides. You actually have some connections to the Carolinas. So with that, I'll kind of let you tell us your story and how you got involved in geology and covering landslides. And I know you have a hydrology background as well. So kind of tell us about who you are and the story that has taken you to where you are today.
All right, great. Thanks very much, Scotty. So I as you mentioned, I'm a research geologist with the U.S. Geological Survey, and my background is in both geology and hydrology. So I started off studying rocks as an undergrad and fell in love with field trips and be able to go outside and look at rocks and landscape features, and figured out that I could do this for a living and continue to learn about the earth throughout my career. And so that's kind of what led me to this general profession. I was a hydrologist for a long time in California, and then I moved out to North Carolina. I was on the faculty at UNC Chapel Hill, and then I had an opportunity to come back to the USGS and work exclusively on landslides here in Colorado. I am stationed in Colorado, but we in the Landslide Hazards Program division of the USGS work all over the country. So most recently, I got back from Alaska. I do work in North Carolina and Washington State and California, all over the country. So I'm not an expert on North Carolina. I know a little bit about some of the stuff going on in the Carolinas and Appalachia, but certainly talk in general about landslides. So I know you've got some specific questions. Maybe I'll just start by talking in general a little bit about landslides.
Yeah, that was going to be my first question. So okay. You could tell everybody, what is a landslide? Sure.
A landslide in the most basic terms is a downslope movement of earth materials. So earth materials being sand, silt, clay, all the sediment, soil, rock, but that also can entrain vegetation, trees, and in the destructive scenarios, also the built environment and cars and in rare and tragic cases, humans. And so there's a number of different triggers of landslides. They can be triggered by earthquakes, by volcanic eruptions, and I assume the main focus here today is going to be on hydrometeorological triggers, rainfall, snowmelt, or rain on snow events. And so that's kind of my main area of focus as well, with a background in hydrology, understanding how the rainfall processes as they hit the ground, infiltrate into the soil, create a wetter, heavier soil that is less strong. And ultimately, a landslide is triggered when the forces that resist failure, namely friction, are overcome by the forces that force failure, namely gravity. So that's kind of the basics of rainfall triggered landslides.
Excellent, excellent. I mean, feel free to go in just a little bit deeper with that. What are some other effects of landslides, causes of landslides, other things like that?
Sure. So to kind of get deeper into the physics side of things, the landslides are triggered. The main thing we kind of pay attention to landslides is pore water pressure. So you're probably aware that soils and earth materials have void spaces, or we call porosity, and that pore space can get filled with water. And once it develops enough of a elevated pore water pressure such that the strength of the material changes, so you add the water to soil and the strength will decrease, and then also the weight increases, so you get a heavier material that's less strong, and that is able to overcome the forces of friction and tree roots and various things like soil cohesion that hold the slope together get overcome, and you have a slope failure. So that's kind of getting a little bit more into the physics of it. There are many different types of landslides, even just associated with rainfall triggering. It has to do with the types of materials, the style of movement. So I can get into some of that too. But the kind of most relevant types for the Carolinas, there's big, deep, slow-moving landslides that may be associated with seasonal activity. So a really heavy winter or a really heavy series of storms in the summer might lead to an elevated water table in a region. So there's higher pore water pressures within that, and that large body of material might move. And then another type that's really common and arguably more destructive in terms of the damage to the built environment and fatalities are debris flows. And those are rapidly moving, almost fluidized landslides that initiate usually after a heavy, intense rainstorm associated with, in the Carolinas, associated with hurricanes or tropical storms. And those also form in a similar physical process where the rainfall infiltrates into the soil, creates a heavier, wetter, less strong soil that fails rapidly. And those can move really quickly, upwards of 30 miles per hour. Typically, by the time they travel down slope, they're anywhere from 40 to 60% water content, and the rest being materials. And they can move an incredible amount of material. They'll move everything and train large boulders the size of houses or small houses or cars in the most extreme cases. They'll take out vegetation and, of course, anything else in its path.
That was going to be my question: is what types of landslides are there, and is there any correlation? I know we hear the term like mudslides, right? Is that kind of the same thing? I mean, we're talking about the same thing in essence. It's just different verbiage here. And the types of landslides that you have, how do they differ on the East Coast versus the West Coast?
Yeah, certainly. Well, the physical principles are all the same, and the gravity overcomes the forces of friction, and there are different terminologies. I should mention the one other type of landslide that's relevant in there, and that actually most recently was shutting down I-40 in Western North Carolina is rockfall. So you may notice from the description of the types of landslides is that they actually have to do with the type of movement and the type of material. And so there's lots of different formal classifications of landslides, and I'm not an expert on all of those. I won't get into that, but essentially the rock fall is very intuitive. It's rock that falls. Debris flow, it's debris that flows. And mudslide is another word that gets, there is, technically there are mudslides that happen as well, but that's typically a more colloquial term for a debris flow. And that mudslides only happen when they're exclusively very fine grained material. And usually once you have that type of a fast slurry of earth materials moving down slope. It's going to be having boulders and gravel and sand and all that stuff in it, which technically makes it a debris flow.
Thanks for that clarification.
If you got specific questions, but that's kind of the thrust of it. Oh yeah, you mentioned the coasts, right?
Yeah, difference between East Coast and West Coast.
Yeah, so the weather has a big impact on that, and the vegetation has a big impact on that, and the soil types have a big impact on that. And so if you have a sandier, better drained soil, then that's maybe able to accommodate a different type of rainstorm than the soils you have where they're higher clay content, maybe a thicker soil with denser vegetation. And so the type of landslide we see is not just related to the climate, but also the landscape that's evolved in that climate. And so in Southern California, a big problem with landslides is associated with post-fire debris flows. So after a wildfire, the fire will take out all the vegetation. It will also, the ash from the vegetation that burned will clog up some of the pore space in the soils. And we also, some of the organic material that burns will create a hydrophobic layer on top of the soils. And you also have kind of a surface crusting. And then also by hyper drying out the soils, cooking all the water out, you also decrease the permeability or the ability of that soil to absorb water. And so after fires, it takes a much smaller rainfall event to generate runoff and debris flows than you might have in an undisturbed setting. So we don't see those as much on the East Coast. We were talking earlier, in 2016, there was a bout of wildfires all over southern Appalachia. There's a lot of concern that there'd be the similar type of debris flow there that we see very commonly on the West Coast and in the Intermountain West. And thankfully, we didn't have that. And that's a process we're still trying to study and trying to understand better, because as we see more and more droughts and intense extreme weather changes, there's the possibility that those wildfires will be more and more frequent, and we may have to worry about that process in other parts of the country.
Yeah, and rolling into that into our next segment, I'm just kind of curious, as far as landslide, forecasting and detection. What kind of tools do you guys have available and that you use operationally, not only to detect landslides, but to maybe try to forecast them before they happen, just to let the public know that hey, you might want to stay on the lookout for this.
Yeah, that is a really great question. That's a big topic of our research. So the USGS, really one of our main emphases is trying to develop research tools and products that will reduce the risk and impact associated with landslide hazards. Honestly, the best forecasting that we have for landslides is weather forecasts. So what y'all do, if we don't know where and when and how hard it's going to rain, we really can't provide much information about landslide forecasting. So to kind of go back to what I was talking about landslide initiation, there's two elements. Well, I guess it really all comes down to that pore water pressure. And so in theory, if we could measure pore water pressure in the subsurface everywhere, we'd have a much better sense of when and where landslides were going to occur. That's very challenging, and we obviously can't do that. And there's been rightly so, a vast amount of resources put into weather forecasting. It's really important across all parts of the country economy, but we don't have quite the same level of resources into forecasting pore water pressure. And so even if you guys did a perfect job of predicting weather everywhere, we still wouldn't be able to predict landslides at the same degree of accuracy. But one of the things that we're really trying to do is develop situational awareness tools for when landslides might be more likely in different landslide-prone areas. And so the weather forecast is a big part of that. The other part that we look at is how wet is the soil before an incoming storm. And so we've got a series of in situ soil moisture and pore water pressure monitoring stations all across the country, where we monitor kind of what we call the antecedent conditions, or how wet the soil is before a storm comes in. And if looking back in the record and seeing how wet soils were before a landslide event, we're able to kind of piece together, and using numerical and physically based models, able to put together predictions about what levels of soil moisture and antecedent conditions associated with how much rainfall are likely to trigger landslides. And so the USGS is in cooperation with local National Weather Service forecast offices to try to communicate that. We don't have 24/7 capabilities, and so all we can do is provide kind of some situational awareness that then the Weather Service can use in issuing alerts.
So you mentioned the poor water pressure sensors and how you wish you could measure everywhere all the time because it would make forecasting really easy. Is that something that is that an actual thing? Meaning in areas that y'all might deem a high risk area for a landslide that are near homes and developments, are there those sensors that can tell you whether or not something may be getting ready to happen?
So currently we don't have those kind of above strategic infrastructure. That would certainly be great. You mentioned later in the show we get to where you can learn more about landslides, but the USGS landslides website does have a link to our monitoring stations, and we do have just about a dozen monitoring stations in different parts of the country in landslide-prone terrain. I'll mention the 3 that we have in North Carolina. One is in Mooney Gap, or in the near Coweta. Another one is in Poplar Cove, which is outside of Franklin, and another one at Bend Creek, which is just outside of Asheville. So we have kind of 3 locations where we actually are monitoring subsurface pore water pressure, rainfall, volumetric water content, these variables that relate to landslide initiation. We're trying to learn more about those specific locations and see if we can use that to extrapolate using models and other process understanding to different locations. And, as a national agency, that's kind of the extent that our resources allow us to do at this point. I'm not aware, but it certainly would be possible for private companies or people to install these same sensors in locations that they were concerned about related to landslides. One of our locations is associated with a railway corridor in the Seattle metropolitan area, and that monitoring effort was initiated by a partnership through a partnership with Sound Transit, which is a railway company. They run a commuter rail up and down the coast, right below some very landslide-prone bluffs, and they wanted to know better when should we avoid running trains below these very treacherous bluffs. And so that's been an ongoing research collaboration with them, and so some of our research has informed their operations. So that's kind of just one example, but we have limited personnel who can work on this. So
yeah, real quick, Ben, I wanted to add to that, and I'll hand it over to Scotty. We talk about, oversaturated soils and undersaturated soils being problematic, especially when you have a wildfire. And you mentioned Weather Service you work with. Do you also work with the drought monitor and seeing where you have drier conditions that may trigger debris flows, or, what other modes of communication do you use to get information across, especially like California, when you see an immense amount of rainfall heading that way? That's sort of an alert to let you know to start looking at historical analysis to find out where we are in the process of their soil content and their capability to retain.
Yeah, sorry, I wasn't sure if you were. So mostly when I talk about the hyper dry soils, a drought isn't sufficient to get things to that really next level of hydrophobicity, we call it. You really need a wildfire, and not just a mild wildfire, but a moderate to intense severity burn. And so our team works, the post-fire debris flow team works in close communication with what are called BEAR teams, burn area emergency response teams, that go into every wildfire and assess the burn severity, the damages, and things like this. And so they're in communication with them to find out the burn severity, which is one of the inputs into our post-fire debris flow models. And then they use that information to produce what's called a preliminary or rapid hazard assessment of the potential for post-fire debris flows. And that gets posted online. And then emergency managers, the Weather Service, and various folks can use that information to coordinate response efforts when there's a storm coming in. So for example, the most recent big one that you probably heard about in the news is in Montecito, California, in January of last year. That was an event where we were aware, in fact, that the storm itself that generated all the debris flows also finally put the fire out. But we were aware ahead of time that there was a storm coming in, and we did our post-fire hazard assessment to determine which of the basins would be most susceptible and the degree of susceptibility. And so all that information went in and helped the emergency planners make some of their mandatory evacuation announcements and things like that. So I kind of steered away from the question of the dry soils. We don't use drought monitoring at all. We mostly care about how wet the soil is or if there's been a fire.
Understood. Thank you for the clarification. Scotty, back to you.
I think you should. I just want to update you. New severe thunderstorm warning issued for Walterboro, Cottageville, and Hendersonville, South Carolina, until 9:30. That in the Charleston metro forecast area. So, Ben, I've been doing some research about landslides. Myself and Evan, we live in Western North Carolina, and so we've heard our fair share about landslides and actually experienced a few recently. 1916, 1940, 1969, 1977, 1985, 2004, and 2018, all years that had some kind of significant landslide debris flow event in Western North Carolina. And out of those events, there was 6 of them that were created from some sort of tropical storm hurricane making landfall either along the Gulf of Mexico or the Atlantic seaboard. So my question to you is how are the tropics and landslides debris flows kind of intertwined? I know working with the National Weather Service in Greenville, Spartanburg, which covers Western North Carolina, upstate South Carolina, when we see landfalling tropical events, when we're expecting to see heavy rains, they always put out this public information statement discussing landslides and debris flows. So can you talk to us about how tropical systems can really enhance these sort of events and why they may be more pivotal for us to watch than any other scenario for landslides?
Sure. Yeah, I mean, again, it really goes all back down to the rainfall and the rainfall amount and the duration of the rainfall. So those tropical storms really carry so much moisture and they move inland and slow down. And you guys feel free to chime in. I am not the meteorological expert, but they slow down and they can dump quite a bit of rainfall in a relatively small location. And so when it comes to the Carolinas, you guys have rain all the time. The soils and topography and vegetation has adapted to accommodate that. And so these rare events that come in, I guess rare in a relative sense, less frequent events that come in and dump a huge amount of rainfall, overwhelm the system that they're beyond what it's really ready to accommodate. And that's what leads to those high pore water pressures that trigger landslides and debris flows. That's maybe the shorter answer. Maybe you want to ask some targeted follow-up questions, but it's really just all about the amount of rainfall that can be dumped in one place. I
guess I kind of follow up with that. You said, they're kind of rare. Evan, please jump in because you and I, we live here in the same area, but it seems like we're starting to see more and more of these happen in Western North Carolina. Do you think that's because we're seeing more heavy rain events, or is it because it's rained so much in previous years that the soils weaken? I mean, could it be because we're seeing more of these events that's causing more heavier rain events, causing more landslides? I mean, Evan, you live there in the Asheville area. I know Interstate 40 at one time last year was totally closed because of this.
Yeah, I can think of 3 on Interstate 40. 40 right here near my house, and the big one just over the mountain just in the last 12 months, all landslides. And one of them shut down Highway 9 for 9 months. If you drive through it, it is a huge landslide. So I think you're right, Scott. Yeah, over this last year, it's just been we've had such an increase in these heavy precipitation events. We've had at least 4 days over the last year where we had daily rainfall totals near or exceeding 5 inches of rain, which that just hasn't happened in years past. And I know that happened in 2004 with Hurricane Ivan and Francis right before it, which we'll talk about here in a little bit. But when those rainfall events start kicking off, it sounds like from what Dr. Ben's been saying that might be, like you said, our trigger, especially because you listed the years earlier. And before 2018, 2004, was the last year with a big landslide. So that's heavy rains in 2004 and then heavy rains in 2018. That seems like a good point.
Yeah, certainly. And I guess I should point out that it's not just the hurricane, the tropical storms aren't, I guess, rare events, but they're not happening every day, every week, all throughout the year. And certainly a sequence of storms are just continued above average rainfall. And that's the case in 2018 and 2013. The landslides weren't associated with any particular tropical system. It was just above average, consistently above average rainfall over many parts of the mountains up there. So yeah, it certainly is an annual thing, landslides there. And it's just that sometimes there's really big ones that dump rain, a large amount of rain over a large area and cause the widespread landslide events that really turn from a landslide hazard into a disaster that affects a huge area.
I know we're kind of, our time is getting away from us, but to kind of add on to that, Evan, we were talking about interstate being closed, but just last year we had deaths in Polk County and as well as Watauga County from this. And so much for, up until last June, North Carolina had cut out research and landslide tool monitoring. North Carolina had cut it out of their budget, and last year, back in June, Governor Roy Cooper pledged so many $1 million to pick the landslide hazard program back up for North Carolina, just because of the recent heavy rain events that we've had. So, anyways, tropics and flash flooding and landslides, at least here in the western North Carolina area, all kind of go hand in hand. So, Tim, I know you had some questions, and I don't want to take up all the time talking about this particular subject because we're going to talk a little bit about it more here in just a little bit.
Excellent. Yeah, I wanted to ask, what areas are most at risk for landslides?
Well, the areas of the Carolinas that have the highest incidence of debris flows in particular is along the Blue Ridge Escarpment, where it's the high elevation, very steep slopes. And that's for a number of factors. The slopes are steep, so the steeper the slopes, the more likely there are to be landslides. But also there's the orographic effect that you see with precipitation or storm events coming in there, and they hit the mountains and rise up quickly and dump even more rainfall. So you have a kind of double whammy of steep slopes and elevated rainfall. And then the kind of on a more local level, we typically think especially about debris flows occurring in convergent topography. So when you have very steep convergent topography, those are areas that are more likely to initiate because you have water that accumulates from all the kind of slope angles converging into what we call a hollow or a zero order channel basin. And then, so as far as the initiation part, that's an area of concern as well. One thing we say as geologists is landslides happen where they've happened before. So Scotty mentioned the state efforts in North Carolina, at least to bring back the landslide mapping effort. That's a big part of landslide hazard analysis, is figure out where landslides happened in the past and how can we learn from that moving forward.
And that kind of goes into what I was wanting to talk about next is, in the meteorology community, and I know you also have a hydrology background. One of our biggest things is communicating. And so we have something called the Weather Ready Nation that NOAA does, and Carolina Weather Group's Weather Ready Nation ambassador. How do you guys at the USGS, how do you guys talk about effectively communicate landslide risks? Do you team up with local weather forecast offices with the National Weather Service? Do you guys have your own safety campaign? How does that work out?
Yeah, well, so one of the things to kind of briefly go back to the state level is that, so we work at the national level, but there's a huge amount of the work as far as landslide mapping and hazard assessment happens at the state level. And so particularly states that have the resources and the landslide hazard issue spend a lot of the time mapping where landslides happened, even developing susceptibility maps. And then the when is something that we work a lot with different state agencies and to kind of develop local relationships that can be useful in different climates and environmental settings. And then the communicating with the weather service side of things, that is also kind of, you're probably aware that each weather service office is distinctly different, even though there's this national weather ready movement. And so a lot of it's developing relationships with individual weather offices where there are people and landslides, and trying to develop a communication where we can communicate to them when and where landslides are likely to be happening, and then they can communicate that on through their weather alerts.
So knowing where a lot of these landslides have happened in the past kind of walked us into the ability to have a conversation about some of these specific events that have occurred both here in the Carolinas and also across the entire United States. Specifically, I know we talked a little bit before the show about the Peaks Creek landslide back in 2004 during the remnants of Hurricane Ivan. Can you tell us a little bit about what happened and what exactly the triggers were for that specific event?
Sure. Yeah. So, I mean, again, it really all comes down to the same physics of the heavy rainfall saturating the soils. And in this particular case, we had Hurricane Francis coming in, dumping, I want to say, on the order of 8 to 10 inches of rainfall. Correct me if I'm wrong. And then swiftly followed by Hurricane Ivan with another similar amount of rainfall. And so when you have a lot of rain falling on already wet soil, then you have really the conditions for debris flows are really ripe. And in that case, there were hundreds of debris flows, mostly debris flows. There were other kinds of landslides that were also triggered, some shallow landslides, some deeper landslides. And I'm aware of about I think at least 5 fatalities associated with that event. Many residences damaged, and I guess there were many counties that had an official disaster response issued. And so that's an example of what I talk about as a widespread landsliding event, because it affected so many people and in such a severe way. And you talk about landslides happening almost every year and sometimes multiple times a year. That's certainly the case. But this is the sort of event we really worry about as a disaster event.
Been piggybacking on that real quick. We're talking about mainly the United States. Let's consider the Caribbean, right? Like U.S. territory. Any of our extensions down there, Puerto Rico, right? Is there a landslide threat down in the Caribbean islands as well? And what sort of thing is driving that? I mean, we have volcanic islands largely, and some not volcanic, but what are the different threats there?
Yeah, I mean, we are working actually pretty extensively in Puerto Rico right now after Hurricane Maria, which generated tens of thousands of landslides across the island. That was a particularly devastating storm, but they have those pretty regularly in the Caribbean. And so what we're doing right now is a 3-pronged effort, kind of trying to understand what controlled the landslide initiation susceptibility in Puerto Rico. So are there geologic controls? Are there antecedent moisture factors that we really need to consider? Ultimately, a huge part of it is just where the highest rainfall intensities were as that tropical storm passed over the island, and it really went right through the middle. Another factor that we're working on is trying to educate the people there about landslide hazards. What are some of the basic things to consider? And this is not just in the Caribbean, but all over the United States. A huge number of the landslides have some sort of human activity associated with that, mostly excavation or roads. So we see a lot of highway road embankments failing because they've been oversteepened or not drained properly. We see a lot of cut slopes on private and public property that aren't drained properly and then develop a elevated potential or susceptibility for landsliding. There's a study I was seeing in North Carolina that 89% of the landslides associated between 1995 and 2016 had some sort of human-involved slope modification. And we see a similar number, about 80%. There's a study on that in the Seattle area. And so there's really a huge amount of this, of the hazard is associated with our own activities.
Very interesting. Thank you very much. I'm sure that applies to Hawaii as well. So the folks over in Hawaii, things there. They have steeper slopes there, so faster moving water. Yeah.
And so it's a combination of, you have to have a steep enough slope to retain some material that can move, and so that besides from rock falling, you have bare rock cliffs that will actually fall down intact rock. You need to have a slope that's not so steep that the soil and rock just falls off right away.
And Ben, so I know we're coming close on your time, and I know you've been at work all day. So one last question from me is, what is the future of landslide study, and do you guys have any new programs ongoing, or ones that you're about to embark on? What's the future look like for studying landslides with the USGS?
Well, there's a number of things. I'd say we're exploring lower cost and more distributed sensors to measure the antecedent soil moisture and water conditions in the subsurface. we're exploring different satellite and remotely sensed products. So there's things like, there's land surface models as well that can give us real-time updates of hydrologic conditions that you probably also are aware of for weather prediction. And so really trying to get at larger scale predictions. How do we go from what we've learned at the small scale to broader scales and really understand why did this particular slope fail, or why is this area failing? And of course, that's going to involve some heavy iteration with weather forecasters to understand the weather systems better as well, and how we can kind of integrate our forecasts and predictions with weather predictions and those services.
Well, Ben, thank you so much for joining us tonight. We certainly appreciate it. For our followers who are watching tonight live, or those who may be listening on the podcast a little bit later on, do you have any sites, websites, social media handles that folks can check out and maybe get a little bit more information if they want?
Sure. The best place is landslides.usgs.gov. And that will lead us to all kinds of things, our research, our information about the post-fire debris flows, our information about landslide monitoring, and even just some general information about landslides. And very soon, we also hope to have a national map of landslide occurrence across the United States. It's not going to be complete, but it's a program that we're starting to try to build up, just so that everyone all across the country can kind of see where is there good characterization of landslides, and do I live in a particular landslide-prone area. So yeah, thank you so much, Scotty. It's been a pleasure, and I hope you guys hope to chat with you guys again more in the future.
Yeah, we definitely would. Definitely appreciate you joining us tonight, and learned a lot. And by the way, for those folks, again, check out that website, especially if you live in Western North Carolina, upstate South Carolina, as we head into this upcoming tropical season. So Ben, you don't have to stick around if you don't want to. I know it's been a busy day for you. We're going to kind of transition into doing a quick recap of what's going on in the tropics with Shay, and then instead of doing our news segment tonight, we do have some severe weather going on in South Carolina and Eastern North Carolina. So we want to talk about that. So Shay, I will hand it off to you first. I know it's kind of quiet after Barry, but kind of give us a sense of what's going on out there.
Yeah, Scotty, thank you very much. Yeah, I'm planning on trying to get some updated information on how much rain actually fell over Louisiana. We did have the initial burst of rain. Barry made landfall as a minimum Category 1 hurricane. Very briefly went back to tropical storm, headed north and up through the central plains up towards Arkansas. And now you can see here on the screen where remnants of Barry are. This is going to be causing several lines of thunderstorms over the next few days, couple of days, especially along the mid-Atlantic all the way up to the northeast, as a lot of inland troughing is going to be sort of edging towards the coastline, caught up along the tail end of Barry. It's almost like a cold front with several low pressures along it at this point. So right now it's moving east at 17. It's really just caught up along a front, and it's going to be problematic for at least the next couple of days before firing off over the Atlantic Ocean and gone for good eventually. So outside of that, nothing to do in the tropics. Everything looks pretty quiet over the next 5 days, and not expecting any development whatsoever. So we're pretty quiet for right now. Again, we got to continue to watch areas like the tropics. I'm sorry, not the tropics, but the Gulf of Mexico and the Eastern Caribbean, as well as the warmer Western Caribbean. And that's an area of concern already. If we get any kind of easterly trade buildup along that zone, along the Caribbean over towards the Western Caribbean, that can mean disastrous results for the Gulf of Mexico, for the states along there. So we have to always watch those this time of the year as waters warm up. Our waters are warming up significantly along the eastern coast, southeast region specifically, into the upper 80s. We hit 87 degrees in Charleston for the first time this year. And so our shelf waters are very warm. The Gulf Stream is still warm. And there hasn't been any activity out there really stirring the waters up. So no cool water upwelling only means the depth of that warm water gets deeper and deeper over time. So back to you.
Shay, one quick question before we go to severe weather. And I know Barry just happened, so we don't have all the information. We've not been able to do a lot of the research. But I had a lot of people ask me, and maybe some of our viewers who are watching tonight, they noticed that Barry was kind of an odd-looking storm. We saw a lot of the moisture on the southern half of the storm instead of the northern half. Can you tell us a little bit about why that might have been?
Sure. Yeah, there was a ridge to the north that was driving some drier air into the northern quadrants of the system. there was a little bit of displacement from north to south, a little bit of upper shear that was driving those cloud tops down. So that's why a lot of the moisture was limited to the south side of the storm. As it lifted to the north, that wrapped around to the eastern side and ultimately to the northeastern quadrant of the system. So it really just took a few days for that Gulf moisture to really start trying to wrap around at least half or more of that storm. But for the most part, right before it made landfall, it looked like the central dense overcast zone of that storm made it very hard to even define a center of circulation on satellite imagery. So it was kind of odd. It was almost oblong in shape, more asymmetrical than symmetrical. But as it really made its way towards land, it really started to tighten up and get that more defined characteristic of a hurricane. And so I'm sure with storm surge and some of the other parameters, some of the Hurricane Hunter dropping signs right then at that point, that 11 a.m. update, they decided to upgrade it to a hurricane, at least while it was making landfall as predicted. So hats off to them for doing a great job seeing the storm coming from days out over the Tennessee Valley, out over the Gulf, and predicting the wind speeds and most everything correctly. There was a lot of uncertainty for the first couple of days. Once it hit water, they did a really good job. So hats off to NHC and everyone involved.
I think the weather Twitter word for the weekend was swirl. I think I saw the word swirl so many times on weather Twitter. So anyways, Barry was a very unique storm, and we've had our first landfall of the 2019 tropical season. So let's talk a little bit about the severe weather. I know, Chris, you and Jared have been monitoring that, so I'll toss the ball off to you guys and let you kind of talk about what's going on right now.
Yeah, Scotty, it's pretty quiet up in Columbia, but I know looking down Jared's way, down 26 toward Charleston, especially east of 95 right now, we got a couple of big storms going. And yeah, Jared, you have it.
Yeah. Let's just go to the radar. Apologies to our audio listeners. I'm going to do something very visual here. Just pulling up the radar here from the Charleston, South Carolina station, and so. First of all, this storm near Walterboro, it's down to a couple trees. We've had a couple storm reports come in from this guy. Nothing too crazy, but it's just one of those situations where you have pulse thunderstorms. It was a hot day. It got to 94, 95 with a dew point at times of 80. I saw 84 today at Mount Pleasant, which was god awful, and I don't think that's completely right. But regardless, we've had a very, very hot day, good bit of energy, and you get these storms that pulse up, and they pulse up, they get really strong, they produce a lot of lightning, and then they collapse, and then the wind comes out of them, get a little microburst action. We caught some of those on our weather stem cameras earlier today. I know we're having some trouble running some video right now, but it was pretty cool. The weather stem camera had a really good shot of a microburst. I believe we're in Raleigh, so that was pretty cool. But as we set this into motion here, you can see this thunderstorm near Walterboro starting the weekend as it moves east. The reflectivity signature is not looking as good. Something kind of following it up on the back end of it, but we are getting to the point where the sun is down. And overall, things will begin to stabilize as the night progresses. Zoom out a little bit from the Charleston radar. We have a few storms rumbling around Hemingway. So, a little rain with your barbecue tonight in Hemingway, approaching Conway, and maybe might make it to Myrtle Beach. Hard to say. We did have a nice thunderstorm come off of Folly Beach earlier. That has since dissipated. With just a few showers left over. And we did have a few thunderstorms up towards the Greenville, North Carolina area as my overtaxed machine moves to the MHX radar. This storm was severe near Greenville and now has significantly slowed down, but we still have a few thunderstorms rolling around Raleigh and Rocky Mountain, those areas as we get closer to Raleigh-Durham, and this is well away from I-95, but there still could produce a lot of lightning. Again, just because a thunderstorm isn't marked as severe doesn't mean it's not dangerous. So just make sure that when thunder roars, go indoors, or in my case, when my dachshund roars, we go indoors. He usually is barking at it about 15 minutes before the onset of the storm, so he's pretty good like that. But anyway, it's July in the Southeast. These things happen at a time, and more hot weather and more storms, leaning more towards storms as the week goes on. Scotty?
Yeah, speaking of that, Evan, I know you live in the Asheville area. You guys had a pretty unique storm yesterday. It just kind of set over Asheville for hours upon hours. You want to talk a little bit about that?
Yeah, it was pretty bizarre, and honestly, don't think I can explain it perfectly. My best guess is that it was so it was a stationary thunderstorm, occurred sometime in the afternoon and really lasted over this thin strip of Buncombe County, and it just kept regenerating and lasted for probably close to 2 hours. It was just a really weird thing, and my guess is that it was triggered by some type of topographic mountain range right near there. It is just downstream of Mount Pisgah, and not, I guess, a little ways north of the Balsam Range, the Balsam Mountains. So I hope maybe it was winds coming up and over Mount Pisgah and triggering that storm. It was just kind of a bizarre storm. It doesn't happen very often like that. But it dumped 3 to 4 inches of rain.
Sure, there wasn't a plane up there seeding it.
Yeah, some chemtrails. I had seen a plane come over earlier, but just kidding. No chemtrails were involved. But it was weird, as you said, Scotty. I don't exactly know how to explain it.
I know our friend of the show, Jason Boyer, chief meteorologist at WLOS. He took pictures and videos of him sitting in his car waiting for the heavy rain to stop so he could go into Channel 13 there. So
yeah, I was about 3 miles north of the rain band, and cutting trees at work. And the whole time, you could hear a little bit of thunder, but it was mostly just heavy rain. You could see just that dark cloud just constantly moving past, but never shifting north and never shifting south.
Pretty unique thing. So I thought that was pretty crazy. Peter, up in the Northeast, you guys dealing with thunderstorms, and I want to talk to you first about the thunderstorms and the heat, and then I'll bring it down to Chris because South Carolina a little bit more used to the heat. But you guys are about to get really hot up there. Talk to us about that.
Well, first of all, while you all were talking during this show tonight, I caught this nice little lightning bolt out the window. So there you go. That's the remnants of Barry coming through tonight. And we did have a little bit of severe weather, lasted about an hour or so, but it's all over with now. And yeah, so there you go. So luckily the power stayed on and everything's good. But now we're dealing with the heat coming up the end of the week. We're going to be sitting in the upper 90s with heat index anywhere from 105 to 110. And Saturday is going to be the hottest day. We're going to have an air temperature of 100, which never happens, and a heat index of like 110, maybe to 115. So very, very hot. I hope everybody's air conditioner is working because it's going to be bad. But we'll finally cool down maybe by Sunday night or Monday with more storms. So we'll see what happens with that.
Well, you get a little taste of our territory.
Yeah, exactly.
And Chris, talking about the heat, I know you've been looking at that in South Carolina, so I'll let you kind of talk about that, and then I can talk about what to expect here in North Carolina.
Yeah, Scotty, everybody knows it's late. We're really getting into late July, so it's going to be hot in South Carolina, especially across the Midlands. We just get that downslope flow a lot of times coming off the mountains, and by the time it gets to Columbia, it's just like a convection oven. But yeah, today we got to 97 or 98 at the airport, and going through the next 3 to 5 days, it's going to be much of the same with temps in the upper 90s, 97 to 98 each day with really, really high humidity and dew point values. That's going to be really up there, making it feel oppressively hot. If there is one silver lining in this, it's starting really tonight and throughout the day tomorrow into Friday, we'll have a little trough develop on the east side of the mountains right over us, and with that, it's going to be a little better dynamics to support more scattered storms. The only drawback to this is the storm motion really tomorrow and Friday is going to be pretty slow. So any storms that do develop, especially tomorrow afternoon, may present a localized flash flooding risk, along with all the other stuff, cloud to ground lightning, and maybe a couple downburst or microbursts here or there. But yeah, I mean, late July is what we expect. But yeah,
definitely saying.
I totally agree with you. It's going to be like that to the coast too for the folks along the coastline, especially with the sea breeze piles up the storms inland. So we'll have to look at slow motion for storm velocities and everything like that as well, all the way here. I think one of the things to take away is when we have these heavy rainfalls, a lot of times they're in the afternoon, but at nighttime, these outflow boundaries that kind of get shot out when these storms go around, and then they trigger more storms at nighttime, which actually trigger more storms in the daytime when you have saturated areas. So it's almost like a cyclical pattern with water on the ground, feeding more water aloft the next day.
Yeah, and Shay, talking about those microbursts, we've got that video pulled up here in just a second. James has got that. I want to share a screen with you as we talk about the heat. This is what we can expect here in the Carolinas. Oh, you don't want to see that. I want to see this. This is kind of the heat index. And as you can see here, I'm going to highlight Charlotte, North Carolina. Somehow Chicago gets highlighted too, but we're going to look at Charlotte. And you can see these are kind of percentages of heat index. And you can look at this. There's a 59 to 60% chance that heat indexes in Charlotte on Saturday it could reach 105 degrees. If you look on Sunday, 48% chance of heat index of 105 degrees in Charlotte. And I think that's the criteria in the Charlotte area for heat advisory. So be on the lookout for that. 88% chance of seeing the heat index at or above 100 degrees on Saturday, and then an 81% chance of seeing that in Charlotte. So on Sunday, and if you look at Charleston, I found this, there's an 11% chance. I mean, 11's pretty high. Looking at this, 11% chance of seeing a heat index of 110 or greater. And then you look at Sunday, that goes up to 26% chance. So there's definitely the possibility of seeing some serious heat in North and South Carolina. And then we'll go up to Asheville, where Evan's at. You can see the numbers are a lot lower. But then we get to a 5% chance of the heat index at or above 100 degrees, a 25% chance of the heat index at or above 95 degrees. So that is 95 degrees heat index in Asheville is pretty high. I mean, that doesn't happen often in the Asheville area. So that just kind of shows you the heat that's going to be coming into the area over the weekend. And as Peter alluded to, we are seeing signs of a cool down as we close out the end of June and July, and the possibility of seeing an increase in precipitation. So as Mother Nature likes to do, it kind of balances itself out. We may have a hot beginning of the month and then a cooler end part of the month. So definitely the chance of seeing some pretty hot and likely dangerous conditions over the weekend. So if you're out in the Carolinas, anywhere from the mountains to the beaches, be sure to take those heat precautions into play and keep safe out there. Find you an area, lake or creek or pool or something like that, and just cool off. So James, I think we have you now. So you want to show us that cool footage that you guys stumbled upon on yesterday?
Yeah, we just mentioned a moment ago the possibility for microbursts in the forecast for Thursday. Check out this video from Tuesday in Raleigh, captured by the WeatherStem camera atop the North Carolina State University's Carter Finley Stadium there in Wake Forest. You can see the microburst, that's the thunderstorm there, collapsing, and those winds coming rushing out of the storm like a center column that then hits the ground and fans out. The National Weather Service tells us 2 to 3 trees in Oak Park community were downed because of this storm, and so it's a great visualization to what we are so often trying to tell you, is that a microburst, like you're seeing here on the screen from this WeatherStem camera, can cause trees to come down or potentially cause even other damage. Sometimes that damage gets confused for a tornado. It can be so severe, and this camera, guys, just happened to be in the right place at the right time recording as we witness this wet microburst in Wake County on Tuesday.
Yeah, and that's a great visual of what we talk about. And that's why we say wind is wind, no matter if it's rotating or blowing in a straight line. If the wind speeds are high enough, it can cause damage and even some injuries and potentially death. If it's blowing high enough to cause a lot of damage. So we appreciate you watching tonight here at the Carolina Weather Group. I do want to mention next week we're going to be talking about hail and kind of theming with severe thunderstorms. We're going to be talking with Dr. Ian Jamiko. He'll be joining us talking all about hail. He works for the National Hail Institute, and they've been out in the plains over this past spring and early summer chasing storms, kind of like we did a few weeks ago. And so he's going to talk to us about that research and some of the data that they got from that. So we appreciate you joining us tonight. Again, stay safe out there this weekend. Stay cool. Make sure that you get you some rest and stay out of the sun. And if you're doing anything fun, don't forget to send us some pictures. Let us know. Tag us on Twitter or Facebook. We'd love to display those as well. So again, thank you for listening to the Carolina Weather Group. We recommend you following us on your favorite podcast application. Give us that 5-star rating. We'd love to hear about that, and we'd love to hear your suggestions for future shows or future guests. We hope you have a great weekend, and we'll see you back here next Wednesday night for another episode of the Carolina Weather Group.